and welcome to our webinar. This is Sydney speaking, and the subject of the webinar that we'll be having today is we'll be talking about saving programming time. Basically, we'll be talking about templates and how to use modified geometry as well. Okay, I was just told that we're not hearing that well, so just a moment, please. Okay. We'll be talking about geometries and modified geometry, and also about templates and some other tricks that'll help you as we go along in SolidCAM itself. Just a quick reminder that if you have any questions, all you have to do is in our window where it shows you we have to raise your hand. You just click on raise your hand. In the questions area, you write down your question, and when you finish your question, just click on the send button below. And at the end of the webinar, I'll go through the questions and try to answer them with to the best of my abilities. Okay, as I said, we know what the subject is about the webinar, templates and modified geometry. So let's get started. Okay, just a moment. Okay. Just one moment, please. Okay. As I was saying, and let me just make sure the settings so I'm not disturbed during the webinar. I don't like disturbances. Just a moment, please. Okay, there we go. All right. As I said, what we have on our screen right here is a very, very simple part. I hope everyone hears me okay. If not, just write it in the question area. Tell me that you don't hear me. Otherwise, I'm assuming that everything is okay, because everything on my side seems to be okay with all my indications saying that my sound is okay. Okay, as I said, we're going to start off with this part, a simple part. And the first operation that I'd like to do, when I see a part like this, actually, the first operation that we like to do is usually do a face mill on top of the part itself. Now, if I take a look at the dimension of my part over here, we see it's 104 millimeters. And actually, I'm going to use a 125 millimeter face mill to face off the top of the part itself. And when I do that, I can actually do it with one pass over the top of the part itself. So if I go into the operation that I've created over here, you'll see I'll be using a geometry which is around the part itself. And I have my tool, as I mentioned, 125 millimeters. My levels in this particular case, I said I want to start 1 millimeter above, go down 1 millimeter, step down, basically all in one shot. If I go into my technology, one more thing. And since I'll be working from the outside, I'm going to actually go down bring my safety distance down to 0.5 millimeter instead of your typical 2 millimeters, which you normally have. Okay, I'm going to start again because I see people didn't see my screen. You should be seeing it now. Okay. All right, as I said before, sorry about that little technical thing. I forgot to push something. Here we go again. All right, as I said, this face I'd like to actually mill on the top over here using a face mill. The diameter, the dimension over here of this line over here is 104 millimeters. And I'm going to be using a 125 millimeter face mill to face off the top. And I'll do this using the option of one pass in my face mill operation. If I were to go into the operation itself, you'll see that I'll be using my geometry around the part. And I have my tool, which is a 125 millimeter end mill. My levels, I'll be going from my upper level of 1 millimeter above the top, going down 1 millimeter. In other words, bringing it down to the 0 level. And since I'm working from the outside, I'm taking my safety distance down to a 0.5 millimeter instead of my traditional 2 millimeter safety distance above the upper level. And if I go into technology, you can see I'm working one pass. And in my offsets, I even set it that I'm going to have a step that's going to leave 0.2 millimeters and then do a finish cut on the floor itself. Taking a quick look at the simulation itself, and I'll use Solid Verify to show this, you'll see that the tool actually goes down. It's your typical case. The tool goes down, goes across the part. You can see it's 0.2 millimeters. You can see over here in my Z, it's 0.2 millimeters above the 0 level. Continue on, going back, now it's at the 0 level, cleaning off the part. Now that's fine, no problem with that. Now, if I actually think of what I just did, this is something that I typically may do almost every single time I work on a part like this. I'll take my end mill, I'll take my face mill, go over the top of it, clean it off, and what I'd like to do is actually save time programming these movements over here. I'd like to actually keep this as a template. This way, every single time I have a part like this, all I have to do is load the template, put the geometry in, and that's it. I don't have to bring in my tool. I don't have to bring in, tell it how deep to go. This is exactly the way I want to work all the time. And I also want to work one pass in these particular cases. So I can save this as a template, and this is done right within the operation itself. Now, by the way, the option of templates is available not only in face milling, but it's actually available in every single one of the operations that we have in SolidCAM, whether it be profile, whether it be iMachining, whether it be HSM, HSS, 5-axis, slot milling, anything that you want, every single operation has the option of saving it as a template. So let's go and save it as a template. Now click on Save. You can see I have several templates here already, so I'll save this new one. I'll give it a name. We'll call it FM for face mill, something that'll actually make sense for me. I'll write down one pass, so I know that this is a template for one pass, and it's 125 millimeter as my tool. And I'll also have checked off over here, include tool data. That means the tool data will also be included within the template itself. I'll click on OK. And now we've actually saved the template directly from the part. Now, before I actually go and use a template, let me actually load a different part that I have over here. The part this time is very similar, but this time the part over here on top is 154 millimeters. And for some reason, the only face mill I have, let's say, is a 100 millimeter face mill, or in other words, my face mill that I have is smaller than the area, which is also going to be a very typical case. So in those particular cases, I don't want to use one pass. I want to use the option of hatch. So again, I have my face mill by geometry. I have my tool, in this particular case, a 100 millimeter face mill. My levels, the exact same way I had it the last time. Technology, working hatch, also floor offset. Again, I'll save this as a template as well. I'll call this one FM hatch. Remember, the name doesn't really make a difference what you call them as long as it makes sense to you. And I'll write down 100 millimeters. Again, include tool data. So now I've created two different templates. Okay, I finished all my work, everything's fine. Now I'm ready to start a completely new operation. New day has come. I'm going to load another part that I have over here, which does not have any operations on it, or shouldn't have anyway. And as you can see, I have a part here that has absolutely no operations done on it yet, and I actually want to start working. Now, looking at the part itself, the length over there is 90 millimeters, so I have no problem using my one pass. I actually want to do one pass on top of this. This is my typical one pass operation. So I'll go into my 2.5D operations pick face, and I'll go directly to open templates. Load a template. Note now I see two templates here. If you remember correctly before, I had a list of several different templates, but now the only templates I see are the ones that have to do with face mill. In other words, it filters out automatically and shows me only the ones that are actually involved with face mill. So like I said, I want to use my first one over here, one pass. I'll load my one pass, and you'll note, and I'll use my geometry. In this particular case, I'll use the geometry, the target, and that's it. You'll note that my tool is here already because it's loaded from the template. My levels, I'll just put my level over there at 1, and my technology, everything is one pass. I'll go back to levels again, by the way. You'll note 0.5 millimeters as far as the safety distance goes. Let's just do a quick simulation on the part, and you'll see that everything is done already. Notice I did not have to pick the tool or one pass or anything else. All I had to do was pick my geometry, load my template, and pick my geometry, and everything was all set. Now let me load another part, similar part to this, and here we go. And it's a very similar part, however, this time it's wider. So this one I want to use the option of hatch. So again, I'll go into 2.5D. I'll choose the option of face. And this time I'll even choose my geometry beforehand. I think I even may have saved it from one time I've done it before. I have my geometry from over there. And all I'm going to do is load my template of hatch. All I have to do now, just to make sure everything's okay, and you can see my technology, everything's at hatch already, my level 0.5, run my simulation, again, solid verify, and you'll see that my tool goes down, works exactly across the part, doing the finish as well. Okay, now I'm going to stop for a moment with templates, and I actually want to go into modify geometry option, and then from there we'll go back into templates as well. Now let's continue on this part itself. And if we take a look, what I'd like to do right now on this part is to mill out this slot that goes around over there. But the way I'd like to mill this out is I'd like to first take a tool that goes through the middle of the slot itself, and then have another operation that will actually clean off the walls themselves. Now, normally when you want to do this with a regular profile operation, to do just the middle, you'd need a profile in the middle and work center, and then do another operation of the two walls to clean off the walls themselves. Let's see how and actually I'm going to start doing that. I'm going to actually start a profile operation. I'll create a geometry. My geometry being, let's say we'll take this edge first, automatic Z, and then we'll take this edge over here. Again, automatic Z, automatic constant Z, and that's fine. Now the tool that I will be using in this particular case will be an 8mm end mill. Now I want as I said, I want the 8mm end mill to go exactly in the middle. Now before I go, let me just choose my levels. My levels will be down to that surface over there. Now, let's go into our technology. Now, if we take a look, if you remember correctly, I actually created 2 chains, but right now I first need only 1 chain. So instead of creating a geometry with 1 chain only right in the middle, what I'm going to do is I'm going to use the option of modify geometry. First of all, if I go into modify geometry, and let's take a look at this using the top view of the part itself, and I'll zoom in also so we can see this. We can see actually both our geometries both our chains, this one over here and this one over here. We can see exactly that the tool is working to the left of the geometry. So first of all, as I said, we only want to use 1 geometry at the time. So let's first get rid of 1 chain. We're going to only use 1 chain over here, and I took the check mark off of the first chain, of the second chain. That way it will only use the first chain. Now, I also want to put this center of the chain. But putting at the center is not enough. Why? Because I actually want to have that chain offset. I want to have the chain offset towards the middle. So for that, we have the option. I'll mark my chain off over here. And for that, we have the option of modify offset. Now, if I know the halfway value between here and here, I just can go over here and write it in. If I don't know the value, I don't really have to know the value. I can actually click on take half of selected offset. Then when I put my cursor in here and click on the second geometry, where I want the halfway distance to, it'll automatically create a chain exactly in the middle. And that's all I need to do. Now, I did not have to create a sketch to do this. Now, let's take my depth type, and I'll have my depth type at helical. Notice it's going to go in around the part in the helical fashion, and my step down, let's say we'll have it at every 2 millimeters. Let's take a look at the simulation itself, and you'll see I'll do this slowly. The tool will go down in the middle and work exactly in the middle of the part itself, going down in the helical fashion around the part. And this is fine. It's exactly what I wanted. But now I need another operation to clean off the walls. But note, I've created a geometry already. This geometry is actually created with 2 chains. Even though in this operation you only use 1, the 2 chains still exist. So all I have to do now, save and copy, go back to my technology, go into my modify geometry. I'll use the second chain. I'll put this back at left, and I'll change my offset back to 0. And I'll say also apply to all. Let's take a top view of the part itself, and we can see now that the geometry is exactly where I want it now. It's using both of them, and it's on the left side off the wall itself. Going back into my operation, if I want, I can also, as usual, add a link. Or, by the way, I'm going to get rid of the helical and just going to do constant all the way down to the bottom, or whatever step down I want. My link, I'll have an arc lead in of, say, 1 millimeter into the part itself, radius, and the same thing with my lead out. Let's take a quick look at the simulation itself. You'll see that the tool will go in, as shown over here, and clear off both walls. Note, I did not have to create a new geometry. I have used the exact same geometry in both operations. But, let's go back to the part now, and let me look again at this part. And if I take a look at the part, you'll note that there are actually some slots up on top over here. And I'm actually saying to myself, you know what, the same technology that I used for this slot down here, I want to use it for these slots here as well. Basically going down the middle and then clearing off the walls. So what I'm going to do is actually take these 2 operations that I created over here, if I want. I can actually create a template from that as well. And this is actually a group template. Right click over here, create template. And I'll call this, for example, slot. Like I said, give it any name you want, and I'll say okay. Now when I go into operations, I can add the option of add operation from process template. This is what we call a process template. Load my slot, click on OK. All I have to do now, I can do right now, is define my geometry, and my geometry is going to be this one, accept it, and this one over here, accept that as well. You know what, let me do actually all of them, because there's something else I want to show you. Oops, I forgot to accept it. There we go. This one now. This one. This one over here. This one over there. This one over there. And this last one over here as well. Okay, they're all working on the left side to start off over here. That's fine. Now, the depth, I can take it directly over here. Upper level is over here. And my depth itself will be up until this floor over here. That's fine. We'll save it. Now we have the two operations created, but now I have to do some other touch-ups. For example, I have to separate my change. You'll note that in my levels, everything is correct. My 0 and my 5 over here. My tool is here already. My technology is center. Okay? It's working helical. However, let's go to my geometry. We'll go to the top over here. And you see we have everything in the center right now. But first of all, I don't want to use all of my chains. I'm going to get rid of every other one. This way we have each one as shown over here. And let's go to the first chain, which is this one over here, the one that says 1 on it. And we're going to actually shift it halfway to over here, as shown over here. But since I want to do the exact same thing for all of these, I'm going to click on apply to all chains. When I do that, you'll note all of them have moved to the middle. Oh, sorry, wrong one. Apply all to chains. There we go. There we go. Now we see that they've all moved to the middle. Now, in addition, what I'd like to do is I actually like to change the start point. I'm going to move it out by 4.5 millimeters. And the same thing with my end point over here, also 4.5 millimeters. As you see, it moved out. And I'm also going to click on apply to all chains, as shown over here. Now, all of the chains are exactly the way I want them. Click on OK. Let's leave everything just exactly the way it is. Save and calculate, run my simulation. And as you can see, I'm going to try to do this a little slow. I'm going to actually do this one step at a time. My tool goes down, back and forth on each one of those slots, exactly in the middle. Now, going to my next operation. My next operation, actually, everything is there already. My tool is fine. My levels are fine. My technology is still on left. My geometry over here, everything's exactly the way it is. Maybe the only thing I want to add on over here is the additional 4.5 millimeters in the beginning and 4.5 at the end. Apply to all. And that's it. Save and calculate. Simulate. Again, one step at a time. You can see it's going on the walls itself. Finishing everything off over there. So first of all, what we've seen actually over here, besides the templates, we've also seen the power of modified geometry as well. I did not have to create separate geometries to clear off these areas over here, to first go in the middle and then go off the sides. All of this was done within modified geometry, where I can use only some of the chains and not all of the chains, or use all of the chains, shift the chains over, and so on and so forth. Okay, now let me actually continue now. And what I'd like to do, continue on this part, is to actually create a chamfer on these edges over here, just to break the edges, which is actually very common, something very common. But not only that, I'd actually like to also break the edges on these edges here as well. Okay, so we'll start with the first one. And I'll actually go into 2.5, and I'll use a simple profile operation. We'll choose my geometry. And let's go over here. We'll start off with this one, constant Z. This one, constant Z. This one, constant Z. And this one here, constant Z as well. So we have our 4 chains over here. Next, I'll be choosing my tool. In this particular case, since I'm creating a chamfer, I'm going to use a chamfer tool. And note the chamfer tool is 6 millimeters in diameter. Okay, we'll select the tool itself. When I go into levels, my upper level will be the top over here. Now, as far as my lower level goes, my profile depth, I'm going to write in here actually the size of the chamfer that I want to create. If I want to create a chamfer that's 0.3 millimeters, then I'll just write in here 0.3 millimeters. Now let's go into technology. Into technology, I'm actually going to use the option now called Rest Material Chamfer. If I open up the option, you'll note that we have the option of chamfer. When I click on chamfer, it'll automatically open up a new tab called chamfer and put me there as well. This is together with the technology tab that we have on top. Now we also have a chamfer. Now, my cutting diameter, the actual, even though it's a 6 millimeter chamfer tool, I can decide over here what is the diameter I actually want to start cutting with. In this particular case, I'm going to leave it at 1 millimeter. I'll have my link lead in and lead out with a regular arc. But let me go back for a moment to my technology field and into technology. Note the compensation. I would like to suggest that everyone, when you do this, do not use compensation. If you need to change the dimension of the chamfer, whether it may be too big or it's too small, don't use it on compensation on the diameter of the tool. Rather, change the depth on the offset of your tool in the machine itself. That will actually, once you do it over there, on any single level you use this tool, it'll work perfectly well. And there's another reason why I would not use compensation here, but I'll get into that in a moment. Okay, let's do save and calculate and run our simulation. And as you can see, our tool will go down. Okay, note it's a 3 millimeter, it's a 0.3 millimeter chamfer that I want to create. And it's a 1 millimeter diameter. I'm using a tool. And if I have 90 degrees, that's like a 0.5 millimeter. So it's a 0.5 millimeter plus another 0.3, which gives us a Z of 0 minus 0.8. Let's take a look at this actually right now in the side view. And you'll see that if I zoom in over here, you can see that here's the tool. This is diameter that's working over there. And this is the kind of chamfer we're actually going to get on the part itself, as shown over here. Let me just run this now around the part itself, and you can see the actual chamfer that was created on that area. Now, as I said, I want to create a, I'd like to create a chamfer on these areas here as well. First of all, let me run my, let me go back into the operation. And since I'm going to be using a chamfer, let me just do a simple save and copy and change my geometry. I'll create a new geometry and we'll go into this area over here. I'll choose that as my first edge and this edge as my second edge as well. Actually, I can do it on all of these, but let's just leave it now just for these two edges. And you'll understand basically it can be used for the other ones as well. We'll accept that. The tool, same tool, levels. My upper level is over here this time. And I'll be going down 0.3 millimeters. In my technology, again, we're using a chamfer, but if I leave it exactly the way it is now, except for one thing I like to change still also, is my approach. I'll have it as normal instead of arc. If I leave it exactly this way, let me start my simulation from the beginning. I see there's a little problem over here. Okay. We have our, now look what happens when I run my simulation on this area over here. The tool will go down, it'll go in, go across, go up, and it did exactly what I asked it to do. Okay? It came from this edge all the way to this edge, but obviously it's working according to the 1 millimeter diameter of the tool itself. So it's actually going to go pretty deep into the side over here. So first let's make one change. Our first change I'd like to make is if I go into my technology and if I go into the area of chamfer, I'm going to change my cutting diameter to be much larger. Let's use 5 millimeters for now. Okay, now, because I'm doing something like this, on purpose, I'm not using compensation. Note, I'm using the same tool in two operations, but in one operation, it's using a 1 millimeter diameter of the tool. And in the next operation, like now, I'm using 5 millimeters of the diameter of the tool. So that would be kind of problematic on the machine as far as which diameters you're going to use for compensation, since it's the same tool. I know there are ways around it, but just simply getting rid of compensation will take care of it. And if you have a problem with the diameter, with the size of the chamfer, just set the depth of the tool higher or lower in accordance. Okay, like I said, I've created now a chamfer using 5 millimeters of the diameter of the tool. Let's run our simulation. I see I have a little problem with my simulation over here, so I'll run the whole thing again from the beginning. Now let's go to the next one. Again, it'll go down, but this is still not enough. No matter what, it's still going to the very end over there. And every single time I go to the very edge over here, it'll always give me a little gouge into the part over here, more than I'm actually asking for. And this is actually on every single one of those corners. So what I can do is very simple. Let's go into my technology, and we'll go into the option of modify geometry. This time, we'll take again a look from the top view over here itself. If I go into extension, I'll actually make the extension at a negative value. Now look what happens over here the moment I start writing. I write minus 1.5. You'll see it actually moved in over here. So the contact point will be over here now. The same thing with the end. Minus 1.5, and since I want to do this for the one on top as well, all I have to do is apply to all chains as shown over here. I'll click on OK, accept it, calculate, run my simulation. Okay, again I'll run it from the beginning and see I'm having a little bit of a problem. And as it's going to do the chamfer now over here, you'll see that the chamfer this time is going in exactly further in over here by 1.5 millimeters. Don't pay attention to this right now because it's just an issue of what we call faceting on the verification stock. But this actually does stop 1.5 millimeters before the edge over there, thereby not going all the way to the corner, allowing us to create the chamfer on that edge over there. Okay, so what we've basically seen in this webinar is 1, the use of templates, 2, the use of modified geometry, and 3, the use of chamfer. 3 points which I wanted to bring out. Now, just a quick word before I open it up to questions is that just like to note everyone, up until now, the option of modified geometry has not been available in pocket operations. However, looking at the development over here, the development actually now, it has it that in 2014, we will be having that modify operation option, modify geometry option inside pockets as well. But not only will we be having it in pockets, we'll even have it inside the drill operation, where I can take a drill and actually give it an offset, move it a little bit to the side if we want to. But that's going to be in 2014. Just a little eye-opener of what's to come in future versions as well. Okay, that's basically it. I'm just going to go over to see if there are any questions over here. There's a question, are there plans to add variables to templates? Not that I know of. However, if you want to have variable templates, that's a different story altogether. We can use machining process, where in machining process, we can actually put in variables, which with any kind of formulas as well, variables, formulas, all that can be put in over there. There is talk about it, but I can't give you a definite answer about having them in templates as well. Okay, now as far as modifying geometry in iMachining, iFinishing, that is also will be coming up as well. It's not only in I see something went wrong over here. Just a second. You don't see my screen as well. Okay, you don't really have to at this moment because I'm not showing anything else. The modified geometry in iMachining will be in 2014 as well. Isn't modified geometry? Yes, that definitely will be there in iMachining as well. And I just, by the way, did check. They are working on, I was corrected, by the way, they are working on putting variables in templates as well. I can't say exactly when that will be put in. Okay. I'd like to thank everyone for joining the webinar.